Question number 10, that's from Electrostatics, and it's again a straightforward article-based question. There are two isolated conducting spheres having radius as 2 by 3r and 1 by 3r. Now, what is there? Initially, they are at a very large distance from each other, and they have charge 12 microcoulomb and minus 3 microcoulomb respectively. Now, these spheres are connected. And after they are connected, we need to calculate the charge on S1 and S2. Now, if I go by the direct formula, Q1 dash is the charge on sphere 1 after redistribution. That comes out to be Q1 plus Q2 into R1 by R1 plus R2. That's how it goes. And likewise, Q2 dash would be equals to Q1 plus Q2, that's the total charge, multiplied by R2 by R1 plus R2. So it comes out to be a very straightforward one. You would get 6 microcoulomb and 3 microcoulomb. Let's go for the next one. So this is question number 11, and this has a nice amount of thought process involved. It is through the topic of rotation, where conservation principles have to be applied. There is a block of mass m and initially moving with a speed v, and initially there is a rod which is hanging vertically and it is hinged at this particular point. Now all the parameters are given, the mass of rod, mass of the block, but let me work in terms of variable. And then what the question says is that as the block comes and hits, the block sticks to one end of the rod. And after that, that's obvious, the rod is going to move further in the vertical plane. So we need to calculate the value of theta, the maximum angular deflection. The question would be split into two parts. First, we would calculate the angular velocity of the rod particle combined system immediately after collision. Now, during collision, a large amount of hinge reaction is generated. But hey, that's not going to create any trouble to us as far as angular momentum conservation is concerned, because torque about this point is 0. And that's a normal thought process that we take. If there is a hinged body, the angular momentum is conserved about that point. That's a first level filter, and that always works by and large. So let's see the initial point. MVL, that's the angular momentum of the block. And immediately after it sticks, what happens? ML square by 3 plus ML square will be the moment inertia of this combined system, and multiplied by omega, because later on it's rotation about fixed axis, so angular momentum is I omega, I being about the axis. So from this we can calculate the value of omega, and after that the rod block system will start moving in the vertical plane. So what is the maximum angle if I want to find? It's all the initial kinetic energy would be equals to the final potential energy, because work done by the non-conservative force is 0. So here, since the mechanical energy is conserved, what is the initial mechanical energy? Let me call this as I. So that's going to be half I omega square. Now omega has been calculated from here, and that is equal to final potential energy. But be careful, for the block it is mgl 1 minus cos theta and plus the rise in potential energy for the rod. For gravitational potential energy, we concentrate at the center of mass, right? So this is mg L by 2 again into 1 minus cos theta. So this is what you need to do, and the answer would come very close to 63 degree. What you can do is that cos 60 is 1 by 2, so the value would be slightly lesser than 1 by 2. So you can make an easy guess. It's not such a big trouble. Okay, now let's go to the next one. Question number 12, surface tension. And this is a very straightforward one. The pressure inside the soap bubbles of two bubbles, that's given 1.01 and 1.02 atmosphere. That means the excess pressure in the first is 0.01, in the second is 0.02. So here what I can do is that the value of excess pressure, of course, is P1, let me write, and P2, okay? That is equals to 4T by R. That's a soap bubble. And that is going to be R2 by R1 because it's a soap bubble, so the surface tension would be same. Now, how much is the excess pressure ratio? That's going to be 1 by 2. That's all. The radii ratio, that's there, 1:2 when we talk about R2 by R1. So the volume ratio, V2 by V1 would be 1 by 8. But the question had asked about the volume of 1 to volume of 2. So that's going to be 8:1, right?